Okay. Make sure, like on number 1 here, we want to look for the highest degree. And I know that a lot of times it's already in standard form, but if it's not in standard form at the beginning, make sure we either number 1, put it in standard form, or at least identify what the highest term and highest degree is. So in this case, my highest degree is 3. So that means it has to be cubic. Okay. And then the leading term is the term that's in front with that highest exponent. And then you have your leading term as well. So, or leading coefficient as well. Okay, in behavior test, and here's what I'll say is that you can put this into your calculator if you want to, but what I would probably do is not, because sometimes when you put these in to your calculator, you might get like a distorted view. It may not give you a great picture of what the graph actually looks like. Try to use that leading term test that we talked about where you have the 4 options. And this one, you're going to go off the highest degree, which is 6, and it has a negative out in front. So 6 would be the same as like x squared because it has an even exponent, okay? And so think about like if I had a quadratic equation. If I put a negative in front of a quadratic equation, what's going to happen to my graph? It's going to flip upside down, right? So it's going to be down, down. So it doesn't matter if it's 2, 4, 6, any even number, they're all going to look the same. Okay, or at least have the same end behavior. And so this one would be down, down. If my highest exponent was odd, like 1, 3, 5, some kind of odd number, then they're going to go in opposite directions. One's either going to start down and end up, or is going to start up and end down. So those are your 4 possibilities. I'm not saying it's wrong to put it into the calculator, but you should be able to hopefully do that without, and sometimes that's a better option anyway. Number 3 is basically the same thing. Now they give you kind of a picture of these graphs, but once again, you have down, up, you have down, down, you have up, up, you have up, down. You have your 4 options, okay? The only difference between number 2 and 3 is they actually give you a picture of the graph, okay? And here, they're just talking about the actual behavior. But those 2 problems are essentially the same thing. Okay, substitution. All you have to do is plug it into the function. Okay, you could also put it into your y equals and see what y values you get if you want to do it that way. But your answer here is a simple yes or no. If we get an answer of 0, then it's a 0. So when I plug -3 in for x, do I get an answer of 0? If I do, it's yes. If I don't, then it's no. Okay, that's all you got to do. Okay, 5 and 6 are basically the same problem, but 5 is in factored form, 6 is in standard form. I'll give you a couple hints here. Factored form is pretty easy. All you got to do is set the 2 factors equal to 0 and solve. The multiplicity is the exponent that's on each parenthesis. Okay, so that one is pretty straightforward. Not much work to do on that one. On this one here, it is an x to the 4th, but what I would tell you on this one, to factor this one, you would do product and sum, just like we did with quadratics. Okay, you're going to do 2 sets of parentheses, you're going to factor it, and then you're going to solve for those 2. Okay, on number 7, and it gives you a lot of information here, but as I read through this, the 29.4 meters per second is part of the equation. So do I need to do anything with the 29.4? Not really, because it's already part of my equation, okay? The 29.4 here, again, is the same thing as that. The 4.9 t squared, if you ever do like physics, this is like a physics kind of problem. But we're also doing algebra when we do this. So the 269.5 is the height. So basically I have two variables here. I have S and I have T. T is time. T is time in seconds. So if I gave you like 5 seconds, I could take that and plug it into the equation. Here, S represents the number of distance of S meters. And so S is my distance here. So when I put this one into my equation, for S, okay? And here's what I'll tell you. This is really just a quadratic equation, okay? And we've talked about these now for all the way back to the last couple of chapters. When I solve a quadratic equation, now because this is a multiple choice question, you could plug and chug, right? You could plug it in, you could check and see which one works. But if I was strictly just wanting to solve this quadratic, the best way to do this would be to graph it. Okay, so I'm going to subtract the 269.5 from both sides, and then I would just have a quadratic equation, and then I would look to see where does it cross the x-axis at. So I would just put minus 269.5 at the end. If I do that, and if you wanted to go ahead and put it in your calculator, you can. You're going to get a parabola that looks like this. It's going to cross the x-axis at two places. It's going to cross it at negative 11, and it's going to cross it at 5, I believe, if I remember right. But because this is a story problem, negative 11 wouldn't make sense. If I said it's going to take this stone negative 11 seconds to hit the ground, right, that wouldn't make sense. And so when we do a story problem, negative answers don't really make sense. And so the only answer here that would make sense would be the positive answer, which would be 5. Okay. A quick and easy way to do that is I could also take 5 and plug it in here and see which one gives me the 269.5. Okay. And so if it's multiple choice, then it kind of makes it a little bit easier, but graphing it would be the way to solve it if you didn't have that. Okay, number 8. Okay, there's going to be several of these where graphing it is okay, but graphing is probably not the way to go. And I would say 8 is definitely one of those. What's the degree of number 8? 3. Okay, it's the highest exponent. Okay, there are 3 things that I am looking for here. I want the maximum number of zeros, the maximum number of x-intercepts, and the maximum number of turning points. Okay, and it's all based off of the degree. So I find my highest exponent, which is 3. If I have a degree of 3, how many times can that graph cross the x-axis at the most? 3. Okay, so 3 zeros, 3 x-intercepts, that's the most. That doesn't mean it will cross it. That means it could cross it 3 times. And then your turning points is always 1 less than that. Okay, so all we got to do is determine what the degree is, and that tells me my answer. These 2 numbers should always be the same. The number of zeros and the number of x-intercepts should be the same. Turning points is always 1 less. And the reason why I would say don't pay attention to your graph there, I think you get a graph that looks something like this on that. And it doesn't cross the x-axis 3 times. So that might be a little confusing, right? I mean, you look at it, it's like, oh, well, it doesn't cross it 3 times. That's just the number of times it could cross it. And that's what we're trying to find out there, the maximum number of places it could cross. Okay, number 9. This is already in factored form. And so when you graph this function, the first thing that I would do is, could you graph it? Yeah. And will I probably have you graph it? Well, we're going to graph it, so yes, for sure. But knowing where all of these zeros end up is going to be important, okay? This has 4 different factors. It has x. There's nothing connected with the x, so that's just x, okay? So x equals 0 is one of my zeros. X equals -2 is a 0. These are all pretty easy to solve. And you probably wouldn't even have to write them out as an equation if you want to, because they're all one-step equations. Sometimes it may not always be a one-step equation. But those are the 4 places, 0, -2, +2, and -1, that this graph is going to cross the x-axis. Okay. And then we just kind of want to come up with a sketch. And the sketch doesn't have to be like real in detail, but we kind of want a sketch that shows what the graph looks like, and it's got to hit those zeros at the same time. So you don't necessarily have to find like the minimums and the maximums and the y-intercept and all that here. But when we graph this, and you can definitely put this into your calculator, it's got to hit all 4 of those intercepts. Okay, and your calculator will kind of help you come up with a sketch of that if you put it in. And you can just put it in a factored form like it's written in. None of these have a multiplicity of 2, right? Remember, if it has a multiplicity of 2, it would hit the x-axis at that point and it would bounce off of it. Okay, all of these are going to go through the x-axis because they all have a multiplicity of 1. So you don't really have anything yet to put on the blank right here. Just graph it and show me what the x-intercepts or the zeros are. Okay, you have a couple of synthetic division problems. On this one, you got to definitely do synthetic division. Remember, what number are we going to put into the box when we start synthetic division? Okay, so if I just give you a function value like this, that's the number that I put into the box, right? But if I give you a factor of x minus 3, then 3 would go into the box, okay? So be careful of, because if you start with the wrong number, then that's going to screw up the whole synthetic division.
So if it's x plus 3, it would be -3?
Yep.
I didn't know if it was just the numbers.
Yep. Okay, so on that one, and then also remember, everything has to be accounted for. So on number 10, I'll just help you get it set up here, and I'll let you do the synthetic division. We're going to put 3 into the box. But we have to put a 0 at the end because there is no constant after the x. Every exponent, every term has to be accounted for. So this starts with 4, 3, 2, 1, but I don't have anything accounting for the constant, so I got to put 0 in its spot. So putting a 0 there is essential because that's going to give me the correct answer. When you do number 11, I know it says synthetic division, but I made this one multiple choice because you can do synthetic division if you want. 3 is going to be the number that goes in the box. Or we also said you could actually put in 3 into the function. Okay. So if I do synthetic division, my answer is going to be the remainder at the end. If I take 3 and plug it in, then that would be the value of f of 3. So either way, okay? If you want to do synthetic division, you can, but you don't have to do synthetic division there. It might be easier just to take 3 and plug it in. I'm okay with it. It gives you the same thing. So whichever way you'd rather go with it. Number 12 is essentially the same thing here as well, except you're doing it for 2 values. You're going to plug in 5 and you're going to plug in -2. The best way to do number 12, in my opinion, is to put it in your calculator. Look at your table, go to 5, do I have a y value of 0? If I have a y value of 0, then it is a 0. And then go to -2. Do I have a y value of 0? Okay, so that's the only question you're asking yourself here. Is it a 0? In order to be a 0, the y value has to be 0. And you're going to check 5 and you're going to check -2. So you could plug each one of those in individually, but I think that takes more time. I think it's easier just to type in the equation into y equals, and then go to your table and look at your y values that are associated with that. Okay, on number 13. This is asking me to do two things. It's asking me to factor it, and it's asking me to solve it. And we've done several problems like this. The reason I say you don't necessarily have to put anything on the blank is because of the way that we're going to write this. For this particular problem, I know it says to factor it, but this one, we would think grouping would be our method here, but grouping actually does not work here. Okay, and so what I would say is on a problem like this, I probably wouldn't even go to grouping. I would just immediately say, let's find the zeros first. What are my zeros of this polynomial? And then use the zeros to write the factors. Okay, so let's graph this one. Put it into your y. Your zeros here would be -3, 2, and 5. So then the factors would be the opposite at each one of those. But we need both, because it's asking me to solve it and it's asking me to factor it. Now, I know factoring is listed first here, so most people's instinct would be to factor it first, but you can solve it and use the solutions to find the factors. And I think that's the easier way to go. Okay, number 14. I'm going to kind of show you what I'm looking for here, and this is kind of what we did the last couple of days, where we're going to use synthetic division to help me find the zeros. And I know that you can just put this into your graph and you can graph it, but we're going to show how synthetic division kind of gets us to where we need to be. Okay? And so, is it wrong to graph it from the very beginning? Not at all. But I do want to see synthetic division kind of showing what's going on here. And I'll kind of show you what I'm looking for here. Okay, so the first thing would be is to graph it. Anytime it says graph it, I don't have a problem with you using your calculator, but we're going to use it to help us with certain things. The x-axis. So I'm going to start with 1. And I'm going to go through synthetic division. Now here's where you got to be careful again. There is no x, so make sure you put a 0. And it's kind of like what we did yesterday. We talked yesterday about if I already had determined that 1 is a 0, then I better get a remainder of 0, right? And we do. Okay, if I don't get a remainder of 0 here, something's wrong, because we already verified that 1 was a 0. So x equals 1 is one of my zeros. I'm going to take this from a cubic down to a quadratic. And here's where you could use -2 and do synthetic division again, or you can just do it this way. And I think this is a little bit easier, and I think it makes more sense to do it this way. What multiplies to get 4 and adds to get 4? 2 and 2. Okay? So I could factor this into x plus 2 and x plus 2. Or, otherwise known as x plus 2 squared. Bless you. So it would be x equals -2. And then it has a multiplicity of 2. Okay. And the reason why that's important is because we have to account for 3 zeros. And so we're saying that -2 counts as 2 of those zeros. And that's because has two factors, x plus 2 twice, right? If I were to graph this, and this one, we're just looking for a quick sketch. It doesn't have to be perfect. The biggest thing that we're paying attention to is where does it cross the x-axis? And -2 and 1 do that, okay? When we do ones like that, sometimes we might get some answers that are fractions or rational numbers. It doesn't necessarily have to be a quadratic equation, okay? It could be a lot of different things. But we want to try to get it down to a quadratic to be able to solve it. Okay, on number 15, a degree of 3. We're going to write a polynomial of degree 3. And so the first thing that I'm going to do here is write out my 3 factors. Okay, there's a lot of times throughout this review where we're talking about the relationship between factors and zeros. Okay, and we're going back and forth a lot between those two. So x minus 2, x minus 2i, and x plus 2i. We have two imaginary zeros. And so what I would tell you on this one, this is what we talked about a little bit the other day. Do your i's first. Foil those together first. Get that answer. And then take x minus 2 times that answer. Okay. When you do all your foiling here, when you do all your multiplying, you'll end up with a polynomial that's cubic. It'll be x cubed. It'll be a cubic polynomial that have a degree of 3. And it won't have any i's in it. It'll just be a normal old polynomial. If it has i's in it, you've done something wrong. Okay, all you got to do on this one is identify other zeros. And it tells me there's 5 total zeros have to be accounted for, degree of 5. They give me 3 of them. And there was 2 rules that we talked about yesterday. If it has a radical, it has a conjugate. If it has an I, it has a conjugate. -3 is neither a radical or an I. So -3 does not have a conjugate. 3i does have a conjugate. That would be -3i, which would be that right there, okay? So it's either B or C, and then negative radical 3 has a conjugate of positive radical 3. So then that would be C, okay? So either i's or radicals have conjugates. Okay, 17 is very similar to number 15. But here's the trick. They only give me 2 zeros, but one's an I and one's a radical. And based on what we just talked about a second ago, all i's and all radicals have conjugates. So if I have 3i, I also have -3i. If I have radical 5, I also have negative radical 5. So it only gives me 2 zeros, but we really have 4 zeros, and so I really have 4 factors. So the best way to approach this is do the i's together, do the radicals together, get those 2 answers, and you're going to have, so basically you're going to have to FOIL 3 times here. Okay. I'm going to FOIL the first 2 with you, and then I'll let you finish it up. This is very similar to what we did on number 15, just a little bit different numbers. So this would be x squared. Hey, and to save yourself a little bit of time here, these are conjugates. So when I do the outside and the inside, those 2 are always going to disappear, right? Because you're going to have a positive 3ix and a negative 3ix. The 2 middle pieces are always going to cancel out. And then we're going to have minus 9i squared. But it's I squared, and we know that I squared is really -1. So this would become x squared plus 9. Look how all the i's disappear. Okay, same thing kind of over here. The inside and the outside are going to cancel out. This is going to be a positive radical 5x. This is going to be a negative radical 5x. Those two are going to disappear. That'll always happen on conjugates. And when I take a negative radical 5 times a positive radical 5, what happens when I take radical 5 times radical 5? It'd just be 5. Yep. And one's negative and one's positive, so that would be minus 5. Okay. So we foiled these two and get this. Foiled these two and it gets me here. And then we just need to FOIL one more time. Okay. When I do all of my foiling and all my answer here, I have 1, 2, 3, 4 factors. I have 4 zeros. And when I get done, I'm going to have a degree of 4 because x squared times x squared is x to the 4th. So it's just going to be a 4th degree polynomial. The only time you have conjugates, though, it has to have a radical or an I. If it's just a regular old number like, let's say 7, 7 doesn't have a conjugate, okay? Or 3, or any number for that matter. It has to have an I or a radical. Okay, we did a couple like this. We're going to use synthetic division here to find the other zeros. Now, what you could do here, a lot of people will say, I'm just going to put it in my calculator, okay? But if I were to put this one into my calculator, just real quickly, I want to show you what is to go through synthetic division. We're going to put 2 in a box. Hey, and we've talked about this a couple times. Because they tell me that 2 is a 0, I better get a remainder of 0. Okay, notice the semicolon here. It's separating the function from the 0. I have to get a remainder of 0. If you don't get a remainder of 0 here, you got to go back, right? Make sure you get a remainder of 0. My quadratic equation that's left is this. And what we basically know is because it crossed the x-axis one time and I have a degree of 3, the other 2 zeros are going to be what? Imaginary. And really the only way to come up with that is good old quadratic formula. Okay. So it's still up here. So you can still use it. So I'll let you finish it from there. You'll get 2 imaginary solutions on that. Okay, last page here. Number 19, list out all the possible rational zeros. Okay, so this is what we talked about yesterday. This is my p-value. This is my q-value. So p is all the factors of 8. And the sign really doesn't matter here, whether it's a positive 8 or a negative 8. So I'm just going to list out all the things that go into 8. 1, 2, 4, and 8. The q value is 2. So I'm going to list all the things that go into 2. I'm going to take all of the numbers on top divided by all the numbers on bottom. So we kind of want to organize it some way. The first thing I would do is just take them all divided by 1. And when we do that, we're going to put plus or minus on all of our answers. So if I divide all of these by 1, it doesn't change anything. And then I'm going to divide them all by 2. So 1 divided by 2 would be a half. Okay, and then what happens from here, 2 divided by 2 is 1, but I already have 1, so I don't need it again. 4 divided by 2 is 2, but I've already got it. I don't need it again. And then 8 divided by 2 is 4, and I've already got it. Okay, so 1/2 is really the only additional one that I get when I divide by 2. And those would be all of the possible rational zeros of that function. Okay, on 20 and 21, these are strictly just calculator problems. Okay, 21 I think is a little bit easier. Where does it cross the x-axis at? Okay, and I gave you one that's pretty straightforward. One of those answers should match up. Okay, 20 might be a little bit harder. Pay attention to the zeros here. You're trying to find the zeros and you're trying to find the factors. We've done a lot of that today. Okay, so does it cross, like for instance on D, does it cross at -7, -2, and 2? Okay, or maybe it only crosses at one of those three. And then you can kind of do process of elimination and figure out which one has the right zeros. Pay attention that this one is radical 7. So radical 7 is different than 7. Radical 7 would have a decimal of like 2 point something, some decimal. Okay? And so if it crosses the x-axis at like 2 point something, then that's probably going to be radical 7. Radical 2 would be a decimal as well. And so does it cross the x-axis at all whole numbers, or does it cross it at some decimals? And then what are those decimals equivalent to? You can do a lot of work on that one, but because it's multiple choice, you should be able to process of elimination pretty quickly determine which one is the best, or which one's the right one. Okay. Went through a lot, but especially because we had 3 of our sections last week and we had a 4-day weekend, I felt like there was a lot of stuff we needed to talk about. Any questions?